This is Josh White with JW Math Tutoring. Today's video is going to cover the Desmos intermediate skills that you need to know to do well on the digital SAT math test. So let's go ahead and take a look.
But life is a dream that calculus could never predict.
Welcome back to my ultimate Desmos guide to digital SAT math. This video is going to go over what I call the intermediate skills, which are operations and skills in Desmos that are more complex and say more complicated for, typically for medium and hard level difficulty problems than the ones in the core skills video. So these are skills that you should definitely learn if you're aiming to score, anywhere above 600 on the digital SAT math section. So 600 to 700, or even above that. All the things I'm going to go over in this video are skills, are operations in Desmos that you should be aware of and should know how to do. So that being said, I'm going to be working off, again, my Desmos, calculator operations worksheet. There'll be a link to this in the description of the video. The version you see in the video might be slightly different than the one that you download at the link because, I might have updated it or changed, changed something in it by the time that you see this video, but it should be very, very similar. So you can get that. And also the example problems I'm going to go through, there'll be a link to a PDF of those as well. So you can work through those as we go through the video, or do those ahead of time and then check your answers, in the video as I'm going through it. So that being said, first thing I want to go over is basically identifying the radius and center of a circle given its equation. Now, the actual operations you use here, distance and midpoint, basically distance formula, midpoint formula, essentially, these were covered in the core skills video, but I'm going to obviously go through them now in these example problems I looked through. So basically, what you do is you just enter the equation of the circle. It does not need to be in standard form. It could just be in really any form. And then you just need to find essentially the top and bottom endpoints of the diameter. So really it's going to be like the maximum and minimum values of the circle. And then you're going to use the distance formula to calculate the diameter, because the distance between those two endpoints is going to be the diameter. And then just get the radius, you would just obviously divide that by 2. And to get the center of the circle, you're just going to do the midpoint formula with those same 2 points. And then that'll give you the coordinates of the midpoint. So let's look at an example problem now. So I'm on, again, the same worksheet that I used in my core skills video. So here is the equation of a circle. So first thing I'm going to do is just go ahead and graph it. Again, you do not need to put it into standard form. You can type it in exactly as it is listed. So let me zoom out so I can see the full circle here. Okay, so now first thing I'm going to do is find its radius. Note, you want this point and this point right here. These are the endpoints of your diameter. In other words, this point at the top is what you consider your max value because it has the highest y-coordinate value, and down here, your min value because it has the lowest y-coordinate value. You do not want this point and this point. These are highlighted because they are both y-intercepts, but these are not the endpoints of a diameter. So if you calculate the radius using these, you'll get the wrong answer. So that being said, I'm now just going to go ahead. Notice they each have the same x-coordinate of negative 1.5, and I have my two y-coordinates, 12.152 and negative 6.152. So I'm going to go ahead and just type in distance and then type in the 2 points. All right, so let's just double check here. Negative 1.5, I have a 12.152. Yep. Got the comma in the middle between the 2 points, and then down here, negative 1.5, negative 6.152. Okay, so this right here is the distance from top to bottom. So this is the diameter. So to find the radius, I would now just take this and divide it by 2. So the radius of this circle, basically essentially as a decimal is just 9.152. Now, if we wanted to find the center, basically I would do the same thing with these 2 points. And so rather than, actually, I can just copy it here. There we go. So I'll just leave that there. I'll copy this here. I'll get rid of dividing by 2, obviously. And now I'm just, instead of distance, I'm going to find the midpoint between these. So notice it shows on the graph, but I don't know what the exact coordinates are. So now what I'm going to do is I'm just going to click label, and that will show me the exact coordinates. So the midpoint is negative 1.5, comma 3. Therefore, that is the center of the circle. So we have its radius, we have its center. You just graph the circle, use the midpoint formula, use the distance formula, divide that by 2, because technically the distance formula is going to give you the diameter value. And that's the first skill, in my intermediate skills section. All right, so now we can move on and look at the second thing on this page below it. So this is something that we've seen occasionally on the digital SAT, not frequently. Like maybe you would get a question on it, but probably not. But I still want to go over it and just highlight it in case you do happen to see a question that covers it. So this is finding the mean of a data set when the data is given in a frequency table. So frequency table is when you have data that's given in a table with 2 columns. One column represents the values and the other column represents the frequency. In other words, how many times each of those values occurs. So to find the mean, when you have data given in a frequency table, you just type in the operation that we see here on the screen. You type the word total, and then, which basically the total function just sums up, whatever is in the parentheses. And so here, what I do is I type x1, y1. Those are just the entries for each row. And it basically goes down through all the rows, multiplying the x value times the y value, and then it sums them all up. That's your numerator. And then you divide by the total of y1. That's just the sum of the um, frequency column. In other words, total y1 in the denominator. That's the total number of values you have. Okay, so let's look at an example problem and we can see here how it would actually work. Okay, so here is a problem. Here's a frequency table, and basically the left column has the number of birds that were spotted each day, whatever, over a 2-week period. The right column has the number of days that specific number of birds was seen. So in other words, one day this person saw 20 birds. On 2 different days, the person saw 22 birds. 3 days, the person saw 27 birds, so on and so forth. Okay, so we want to know what is the mean or average number of birds that were spotted per day. So here's how we do this in Desmos. Basically, we make a table. The first column, again, is going to be the values. So I'm just going to type all these in. And then the second column, the y1 column, that is the frequency column. Again, going back to the sheet, here it's total x1 times y1 divided by total y1. Okay, so this is going down through and it's multiplying the x in each row, the x value times the y value. And then it adds up all those results. That's your numerator. And then your denominator is just the total of the y1 column. Basically total number of values or total number of entries. All right, so we have the mean here. It comes out to 29.357, blah, blah, blah. So on the test, if this was not a multiple choice question, if this is a free response, what you would technically type in is 29.36, or you could also truncate it and technically put 29.35. Both of those would be considered correct answers. All right, so now let's move on to the next intermediate skill. So this is actually a fairly important one, a fairly common one. It is quadratic function regression. So this is basically if you have the points on a quadratic function getting the equation of that function. Okay? So you can either just be given the points, or you could be given values in a description of a word problem, or you might be given the graph, and you just get the points from the graph itself. So there's two different ways it could be done. There's standard form and there's vertex form. So you can see the equations, well, not really equations, the state regression statements there on the screen. And a couple things to be aware of. If you're going to do standard form, if you do not have the value of A or B or C, you need to have at least 3 points. You can have less than 3 points if you know or are given the specific value for A or B or C. But if you are not given A or B or C, you need to have at least 3 points. Now, for vertex form, it technically only requires 2 points, but one of the 2 points has to be the vertex. And specifically, you have to enter like the H and K values of the vertex in the regression statement. If you don't do that, if you just enter the 2 points in the table and you don't enter the vertex values into the regression statement, you will not get the correct answer. And I'll show you an example of like what happens with that. All right, so looking at this problem, we're given a quadratic function and we're told its vertex, and we're also given one of its x-intercepts, and we want to know what the other x-intercept of the graph is. So this is something we can do easily using quadratic regression, specifically in vertex form. First thing I'm going to do is go ahead and create a table. I'm going to type in the one x-intercept point that we're given. You can type the vertex in the table here, but it's not necessary because, as I said, you're going to enter it in the regression statement. So now I'm just going to go ahead and do this, type in the regression statement in vertex form. Again, notice here, this is my h value, which is -2, and this is my k value, which is +5. So because vertex form is x minus h, it's x minus -2, which really becomes x plus 2. So we'll square that, and then we'll add the +5. All right, so now I have the graph of this quadratic function. Okay, here is the -15/4, -3.75 intercept. Over here is the other intercept. It's at -0.25. Hopefully you recognize that is equal to -1/4. So the correct answer for this problem is just going to be letter A. Now, one thing just to show you, okay, if you did not enter, here's what happens if you do not enter the vertex in the regression statement. So let's say we enter it in the table instead. Okay, and now I just enter generic H and K down here. So again, this is why I'm showing you what will happen if you do not enter the vertex H and K values in the regression statement. So notice here, it finds a quadratic function that has an x-intercept of -15/4, 0, and goes through the point right here of -2,5. But the problem is you want the quadratic function to have a vertex, i.e. in this case a maximum point at -2,5. And this one does not. This has its maximum value, or its maximum, vertex point at 1, 8.318. So this is the reason why you have to put the H and K values in the vertex regression statement, because otherwise it doesn't treat the vertex point as the vertex. It just treats it as any other random point on the quadratic function. Okay, so just to show you, you will not get the correct answer if you do not put the vertex values into the regression statement when you're doing it in vertex form. All right, so now let's look at the next problem. Here we have a situation where let's see here. You have a ball, it's thrown upward from a platform 8 feet above the ground. After 1 second, it's 32 feet above the ground. After 2 seconds, it's 24 feet above the ground. But how long does it take to reach, the ground? So essentially what we have here are 3 points that you're given. Your x is your time or your t-value, and your y is your height. So you have 0, 8, you have 132, and then you have 224. Okay? So what I'm going to do is make a table, put these 3 points in, then I'm going to do quadratic regression in standard form. To get my A, B, and C values. Okay, and we want to know how long does it take to reach the ground. So reaching the ground means that the time, or in other words, the x value is equal to 0, i.e., where is the positive x-intercept happen on this function? So we can clearly see from the graph, it's right here, 2.686 seconds. So that would just be our answer. And there's nothing more to this. They could also ask you for slight variation. They could say like at after at what time does it have a height of whatever feet, 5 feet above the ground or like 10 feet above the ground, and then in that case you just graph whatever it's asking for, like say y equals 10, and you see, okay, well, it's a time of 2.449 seconds, or whatever it is. Or it could say, what is the height of the ball, you know uh 1.5 seconds after you throw it up. And there you could just do like, x equals 1.5, and then you just zoom up on the graph, see where it intersects. Okay, it's 32 feet above the ground. So those are just slight variations of problems that you could see, when you're doing quadratic regression here. All right, now something else related to quadratic equations, quadratic functions, and the next kind of intermediate skill I want to talk about is identifying the number of real solutions to a quadratic equation. So this is basically just the process of graphing the function and then looking for the number of x-intercepts. So the number of x-intercepts is the number of real solutions to the problem. So if it crosses the x-axis twice, the equation will have 2 real solutions. If it just touches it and crosses it once, then it'll have 1. If it does not cross it at all, then it has 0 real solutions. Now, there are a lot of problems that you may come across on a test where you might have to kind of use this operation or use this skill, but also add a slider to figure something out or to find something, to find something out. So let's look at some example problems now. So this first example here, says, how many real solutions does this equation have? So all you have to do, again, you could type in the entire equation and then look for the number of vertical lines. But what I'm going to do is technically move the 20 over by adding it. So that way it's then equal to 0. And then just graph this. And you can put the y equals or f of x equals, but you don't have to. And then I'm going to look and see how many x-intercepts does it have. Okay, well, it currently has 2. So therefore, this equation will have 2 real solutions. And that's it. That's all you need to do. It's just essentially, if you're going to use this method, you do need to basically make sure everything is on one side such that it's equal to 0. All right, next, let's look at another problem where we have a quadratic equation, but here basically we're going to use a slider to figure out what the answer is. So here you have this given equation, all right, and you're told b is an integer, and you're also told that this equation has no real solutions. What is the largest possible value of b? So in other words, how large can you make b such that the equation has no real solutions? So all we have to do is type this in, then add a slider for b. So first of all, let's zoom out here. Okay, see, it's like way up here. So since it's asking for the largest value, and probably going to keep increasing this. Now, I'm going to set the step to 1 because we know it's an integer, so we don't need any decimal values. And I'm just going to, whatever, jump this up to 100. And let's see, how far do we have to increase this? Okay, so now it's starting to get pretty close to the x-axis. Notice when I get to 80, okay, are there any real solutions? Okay, there is, because notice we have an x-intercept. Okay, so 80 is not the answer because we're told the equation has no real solution. So instead it looks like we have to bump it up, 79. So it looks like 79 is going to be the largest possible value for b in this equation to still leave this quadratic equation with no real solution. So in other words, this quadratic function with no x-intercepts. Because again, when I go up to 80, it's down here on the x-axis, there's a real solution. So that tells me that 80 is too high. So the correct answer to this would just be 79. All right, let's take a look now at the next intermediate skill, and this is just factoring a polynomial expression. So all you have to do in order to factor something is graph the function, then find the x-intercept values, and basically each factor is going to be like x minus c, where c is the x-intercept value, and that's it. So let's take a look at an example problem now. So which of these expressions here is a factor of this polynomial 3x squared minus 10x plus 8? So really what I'm going to do here is that I'm going to factor this expression just by looking at its x-intercepts. So one of them is 1.333. So notice if you didn't know that this equaled 4/3, I would just type out a bunch of these and see, okay, so that means one factor is x minus 4/3. And the other factor, okay, it's just going to be x minus 2. So, okay, obviously x plus 2 is going to be wrong because we have x minus 2. But the question is, does this equal this? So what I would do is if you're doing the factoring method, essentially like what you want to do is clear any fractions by like multiplying by whatever the denominator is. So in other words, you multiply both terms here by 3, and that turns this into 3x minus 4. And now you can see that, yes, it does match number 1 up here. So the correct answer for this is just going to be, letter A. 3x minus 4 is a factor of this expression. X plus 2 is not a factor. But again, the general skill here is being able to factor a function just by graphing it, finding its x-intercepts, and then realizing that the factors will be x minus whatever the x-intercept value is. Last operation on the intermediate skills video is identifying equivalent expressions, or really matching two expressions that are equivalent to each other. So there are two different types of problems that you could generally come across with this. The first one would be one where you have x and or y, in the expressions. And if that's the case, generally the easiest way to do it is to graph the expressions that you're trying to match. So in other words, maybe the original expression that's given and then the answer choices, and you see which one overlaps it completely. Which one essentially matches the original expression, has the graph on top of it. Now, if there are additional letters in addition to x or y, then you would just have to add sliders, and add values, for those constants. However, if you're trying to match two things which do not have x or y in them at all, then the approach that you're generally going to take is you're going to type in, say, the original expression. You're going to add sliders for all the letters. And then you're going to say type in the answer choices, and you're going to see which answer choice gives you the same numerical value as the original expression. So you're not looking for like an overlapping graph. You're instead looking for the same numerical value. All right, so let's take a look at some problems now. So at the bottom of the page, this first example, we have a function f of x, and then we are essentially finding a translation of that function. So this actually involves another skill, that's mentioned in one of my previous videos. And we want to know which of these, answer choices down here is equivalent to this new function, not the original, but this new function g of x after the translation. So all we have to do is just first graph the original, okay, then do the translation, which is technically the original shifted to the left 4 units. I'm going to turn off the original, by the way. And now we can go ahead and type in the answer choices, and we can see which one completely overlaps the g of x here, the blue. So far, notice first two answer choices are not overlapping it. Looks like it's going to be D, and you can see here that it is. So notice if I hide these three right here, notice I only have one graph on the screen. That's because the red is overlapping the blue. So the correct answer to this problem is going to be letter D. This is the function that matches, basically the original function f after it undergoes this translation. Okay, so here we have another example problem. Just clear these all out here. Okay, so you have two rational expressions being subtracted, and we want to know which of these is equivalent to this original expression here. So we're just going to go ahead and going to graph the original, and now I'm just going to graph the answer choices. Okay, so notice this one looks pretty similar in some areas, but it does not completely overlap it. So that is not going to be the correct answer. All right, what about B? 5 over 2x minus 9. Nope, that clearly does not overlap the original. Okay, the purple one does not either. So again, this one, it looks like it is going to be D. Okay, so now let's just get rid of this. This is not the right answer. Let's get rid of the green. Let's get rid of the purple. So again, we only see one graph here. That's because the black is completely overlapping the red. So in order to find out which of these expressions is equivalent to this, original expression, I just graph the original, I graph the answer choices, I see which one completely overlaps it, and that is my correct answer. So in this problem, the correct answer would again be letter D. All right, let's look now at an example where we have no x or no y. Okay, so we just have, other letters, in this case A and B. We want to know which of these expressions is equivalent to this fourth root of a to the 13th, b to the 26th. All right, so a couple things. First of all, if you actually want to enter it in with the fourth root, again, you have to go to functions down here. This is covered again in one of my earlier videos. But you could also just do the expression to the 1/4 power as well, like that, because that's equivalent to it. All right, so I have the original expression typed in. Now we need to add sliders for A and B. A lot of times I don't like to use 1 just because, like here, it gives me 1. So we might get multiple answer choices that are correct. So I'm just going to slide this to whatever and slide this to whatever. All right, now I go through my answer choices and notice for A here, this number matches. So that it looks like A could be the correct answer, but I still want to do the others just to make sure that I don't have, potentially multiple correct answers based on the values I chose for A and B. All right, so this is B. This is clearly incorrect. So we can basically get rid of this. Now for C, it's the same thing inside the parentheses, but just change the power to 17th. Okay, that's a gigantic number. Clearly not correct. This is going to be even larger. Yeah, something times 10 to the 30th. So this just confirms the correct answer is A. And again, the method or the approach taken here is type the original expression, add sliders for all the constants, then type the answer choices and see which answer choice gives the exact same numerical value as the original expression. All right, so this was the video on the intermediate skills from my Desmos operations worksheet. So again, these are the skills that you should learn if you're aiming to score, I would say, in the 600 to 700 range, or possibly higher. But if you're aiming to score at least 600 or above, these are definitely skills that you need to know. Again, there's a link to the PDF to these example problems in the description. There's a link to the operations worksheet, get like reference sheet in the description as well. Also, check out the core skills video if you haven't done so already. And after this, check out the advanced skills, which is basically for people aiming to score 700, and above on the digital SAT math test. So if you have any questions or comments, please do leave them below. Otherwise, if you like this video, of course, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And like I said, check out the other videos in my ultimate Desmos guide to digital SAT math.